All right, hi guys. We're gonna do a quick lesson on the Cartesian plane, and this is pretty much review for you, so it'll be real quick. The Cartesian plane is how we do our graphing, and it's not the only way to graph things, but it's the way that we use in math through most of high school. And so it's basically founded on this principle. We have two axes. We have an x and a y. The y-axis goes straight up and down, so I'm using some graph paper. And I would recommend you kind of copy me and do the same thing. The axis that goes straight up and down is called the y-axis. And the axis going across this direction is called the x-axis. So I'm going to label them x and y. And this is the Cartesian plane. And in this plane we can place points. And so if I'm going to place a point somewhere, I can kind of make it up. I'm going to make up a spot. Let's say right here is point A. You can call it whatever you feel like. Well, to actually be able to tell somebody how to get to point A, you need a way of describing where it's located, a direction basically. It's kind of like GPS or something. So what we do is we label our x and our y-axis using numbers, negatives and positives. Positive numbers are numbers that are on the right side over here or on the top. So like this is positive 1, positive 2, positive 3, positive 4. And on the opposite side we have negative 1, negative 2, negative 3, negative 4. Negatives are on the left, positives are on the right. Same for up and down. If I go up, it's positive 1, 2, 3, 4, 5. And you can keep going. You can make this as big as you want. I could have gone up to 10. I just stopped to make it small. And if I go down, I've got negative 1, negative 2, negative 3, negative 4, and so on. So if I'm trying to describe point A, well, I can tell that A is at 3 and 4. So we call that an ordered pair. An ordered pair. You should write this down. An ordered pair is the GPS, it's the direction, it's telling you where is A located on this map. And it's at 3 and 4. So we say 3, 4, and we put these parentheses around it. And basically what we're saying is that this is the x-axis value and this is the y-axis value. So to kind of go off of this problem, let's say I know about a point, we're going to call it point B. And I know the ordered pair is negative 3, 2. Well, if I kind of follow these same directions, this is the x number and this is the y value. So it tells me start at the center here, go to negative 3, so 1, 2, 3, negative 3 on the x-axis, and then it's saying go up to 2 on the y-axis, so 1, 2. So right here, that must be point B. There's also some other kind of unique things about this whole mapping system, this Cartesian plane. One thing we can do is we can label each quadrant. There's 4 sections of this graph, so we can kind of go through and label them. We say this first section up here is quadrant 1, but most of the mathematicians and textbooks that we use a Roman numeral. So it looks like the letter I, but it's the number 1. And then if you go to the left, this is quadrant number 2, but I'm using Roman numeral 2. And then this is quadrant 3, so Roman numeral 3. And then this is quadrant 4. Do you remember what a 4 is in Roman numerals? It's different. It looks like a 1 and a V, or an I and a V, 4. So we have 4 different quadrants, quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And we can place lots of data points in here and then label them with something we call an ordered pair. And that's basically the basics of the Cartesian plane. It's just a mapping guide. This whole entire system up here, this is called a 4-quadrant graph. A 4-quadrant graph. And the name's kind of obvious why it's named that. It's 4-quadrant graph because we have 4 quadrants basically. You can have a 1-quadrant graph. Sometimes it's more convenient. So let's write down here a 1-quadrant graph. And we'll talk about that. When do you think we would want a 1-quadrant graph? Well, up here we've got, sorry to move this around, but we've got 4 different quadrants. One quadrant means we're only in the first quadrant. We don't use the other values. And the reason you might not need all 4 sections is, what if you're dealing with something that doesn't have any negative numbers involved? Then you don't need any of this other side. So a 1 quadrant graph just gets rid of the negative numbers. So I'm going to use my ruler and just draw a little picture of a 1 quadrant graph. It has an XY axis. Going up and down is the Y. So I'm going to label it. And it has an X, but the X is down here at the bottom. I'll put it like right here. X. This is a first quadrant graph. It's only the positive numbers. So we've got +1, +2, +3, 4, 5. I made mine kind of big. You can make it as big as you feel like. And you've got on the y-axis the same thing, positive numbers, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So first quadrant graphs are handy when you only want all positive numbers. You can do the exact same thing. You can put ordered pairs on here. If I was to put a point on the axis, like let's say I put a point here, and I called this point letter C, and I asked you to tell me the ordered pair for the letter C, ordered pair, could you do it? Pause the video and try it. The correct answer is it's at 4, but on the y-axis, it's at 0. So the answer is going to be 4, 0. 4 is the x number, if I want to write a little x down below, and 0 is the y value. So it's right on the x-axis here. So in summary, we've got 2 types of graphs. They're both called Cartesian graphs. One of them is called a first quadrant graph, and the other is a 4-quadrant graph. And this is basically just a big mapping system that in algebra, we're going to use it pretty much all the time. You're going to be graphing constantly. So we should be able to use both the 4 and the first quadrant graph.